Hey guys and girls, so in today's video we're going to be talking about Roblox's client-server model. And then I'm going to be showing you guys how to make an NPC system that almost runs solely on the client side. And if we look from the perspective of the server, there are no NPCs, there are no pathfinding calculations, there are no physics-based calculations, and if we look at the network stats, the overall incoming and outgoing kilobytes a second are close to zero. So the way that Roblox's client-server model works is scripts run on the server and local scripts run on each individual client. When the server creates a part, the part's properties are sent to every client. And if a property changes, for instance, if the part is constantly moving, the server will need to constantly send the position data to every client. But if we use a local script to create a part on the client, then the part's properties will not be sent over the network to the server. Parts created on the server that are not anchored work slightly differently. In order for the server to not get overwhelmed with too many physics-based calculations, it will offload the work to the closest client. So if this client here is the closest client to the unanchored part, this client will calculate the physics for that part and send the updated position back to the server. The server will blindly accept that position and send it to all other clients. In order to demonstrate this, I've created a simple baseplate project with a ball that is not anchored and a dummy that is also not anchored. I'm going to change the settings to R region shown to true and R owners shown to true. And I'm going to start a local server with 2 players. When a player first enters the game, the radius around the character where a player can receive network ownership first starts off small and increases in size as they stay in the game. Here you can see that the yellow player currently has ownership of the dummy and the ball. But as I walk closer with the green player, you can see that now that I'm closer, the dummy and the ball is owned by the green player. And because the green player owns the ball, I can select the ball in the Explorer and set the position to 30, and you can see the position moved for the green player and the yellow player. Now if I attempt to move the ball with the yellow player from 30 to -20, you can see that the ball moved for the yellow player but never moved for the green player. And as soon as the green player touches the ball and updates the position, the yellow player will instantly move the ball back to where the green player says it's meant to be. A downside to this is that hackers are now able to move any object that is not anchored if they have network ownership. For instance, if you have an NPC, a hacker could simply come and move the NPC by simply going like this, and now you can see the NPC moved for not only me but all other players in the game. In order to prevent hackers from moving parts that are not anchored, we can use the set network owner function and set the owner to nil in order to allow the server to keep ownership of that part. So to do this, I'm going to simply add a script to the ball and say script.parent set network owner, and I'm going to pass in the value nil into the function. Now you can see that it's possible for me to take ownership of the dummy, but no longer possible for me to take ownership of the ball, which prevents me from adjusting the ball with local scripts. Another problem that we have is if you have too many moving parts on your server, the server will struggle to send all that information to all the clients. In order to demonstrate this, I've created a simple baseplate project with 6 scripts. The 3 scripts on the left side run on the server, while the 3 scripts on the right side run on the client. The first script creates 200 NPCs, the second script creates 300 parts and uses the run service to position the parts, and the third script creates 300 parts and uses the tween service to position the 300 parts. Here we can see that the red parts that are run by the server are very laggy, and the blue parts that are run by the client are very smooth. We can also see that the NPCs that are run by the server are very laggy, and the NPCs that are run by the client are very smooth. Now I'm going to be showing you how to make an NPC system that has very low network usage and is also not hackable. First, let's create a baseplate project. And within Workspace, I'm going to create a folder, and I'm going to rename this folder to characters. And inside of the character folder, I'm going to create a new folder, and inside of this folder, I'm going to create a part. First thing I'm going to do is anchor this part, and I'm going to change the color. Now I'm going to position this part where I want the NPC to go. So I want this NPC to be here, and I'm also going to duplicate this part, and I also want the NPC to walk over here. Now let's create a second NPC, and this NPC is only going to have a single part, and this NPC is going to walk within here, and I'm also going to rotate slightly, and I think I may rotate these slightly. Now let's create a script inside of server script service, and the first thing we're going to want to do is loop through every folder within the characters folder. So to do this, I'm going to do for I folder in I pairs workspace dot characters get children do. Now I'm going to store a table for every folder. To do this, I'm first going to create a table called characters, and inside of here I'm going to create a table called data, and then I'm going to use the folder as a key to store the data table. Now inside of this data table, I'm going to want to save the C frame and size of every part inside of the folder. To do this, I'm going to simply loop through every child inside of the folder. So we can do this, and I'm going to call this part. And now I want to create a new table called part data, and I'm going to store the parts C frame and size inside of this part data. So I'm going to do dot frame equals part dot C frame, and size equals part dot size. And now I'm going to add this part data into the data table. So table dot insert data part data. And now I'm going to delete the part because we no longer need it. So destroy, and I'm also going to print the characters table so that we can see what it looks like when we run the game. So if we look inside of the character table, you can see that we have the two folders, and inside of this we can see that the one folder with the single part and the other folder with the two parts are storing more tables. So we can look inside of here. Let's expand this out and let's expand these. So you can see we stored the C frame and we've stored the size for this part and for the other two parts as well. Now I'm going to compress this part so it doesn't consume too many lines of code. So what I'm going to do is do this, and I'm going to do this. Now we can remove this, and I no longer need to store it inside of part data. I can just pass the table directly into the insert like this. Now let's create a function that's going to get a random position within a random red part. So to do this, I'm going to first create a function. And I'm going to pass in the folder to the function, and we're going to use this folder to get the data from the characters table. And then I'm going to select a random part within the data table. So to do this, I'm going to say data equals data math.random, and then we're going to pass in the length of the data table. Oops, like so. Now I'm going to create a vector free using the size of the part to pick a random offset from the part's position. So to do this, I'm going to say local offset equals vector3.new math.random, and I'm going to use the size value dot x, and it's going to start from the negative. We're also going to divide it by 2, and we're also going to do the same for the positive side. And for the y-axis, we're just going to pass in 0, and for the z-axis, we're going to do the same as x, but we're going to use the z for the size. And now we're going to convert this offset into world space from object space so we can get the world coordinates. To do this, I'm going to return, and I'm going to do data dot cframe point to world space, and I'm going to pass in the offset. Now I'm going to use this function to save a position attribute onto the folders. So to do this, I'm going to come down here and type in folder set attribute, and I'm going to call the attribute position, and we're going to use the get position function to store the position, and we need to remember to pass in the folder. And I'm also going to create a loop, an endless loop. So I'm going to say while true do, and I'm going to loop through the characters table. So for folder data in pairs do, and I'm going to update the position, using the get position function once again. But every time we update a folder, we're going to wait. For now, let's just wait 5 seconds. Now let's test the game and see if it works. So if we open up the workspace, and inside of characters, we'll see there's 2 folders, and the folder has a position attribute. And if we keep watching, we'll notice that the position should change. So you can see it just changed, and now this position should change, and then another 5 seconds later this position should change. And now I'm going to delete this print, and the server-sided code is completed. But for testing purposes, I'm going to comment out this destroy function, and I'm going to say part.canCollide equals false. And I'm just going to do this so that we can test to make sure that the NPCs are actually walking within the parts. So now let's make our NPC model. To do this, I'm going to come into plugins and use the build rig button. And I'm going to create a block rig, and I'm going to make sure I set anchored to false, and I'm going to create a folder inside of replicated storage, and I'm going to call this folder characters, and I'm going to move this dummy model into the folder, and I'm also going to rename these folders to dummy so that the client knows which model to use as an NPC. Now I'm going to create a local script inside of replicated first, and I'm going to loop through every folder inside of this characters folder and use the name to clone the model from inside of this characters folder. So to do this, I'm going to do for I folder in iPairs workspace, wait for child characters, get children, and then I'm going to create a model. So local model equals game.replicated storage characters, and we're going to use the folder's name. So folder.name, and we're going to clone this model, and then we're going to position the model. So model dot set primary part C frame, and we're going to create a new C frame dot new, and we're going to use the folder's position attribute, get attribute position, and we're going to then set the model's parent to the folder. Now if we test the game, we can see that the dummies are being placed within the red parts. So we can see this dummy was placed here, and this dummy was placed here. But the dummies do not move when the attribute changes, so let's do that. So I'm going to use the attribute changed event, so folder dot attribute changed connect function, and the event passes the attribute, so we're going to store that in an attribute variable, and then we're going to check to make sure that it's the position attribute, Now currently the attribute will always be position, but you may want to add things like health for future updates. And now I'm going to make the model humanoid move to the new attribute's position. So I'm going to say model.humanoid move to, and I'm going to get the folder's position attribute and pass it into the move to function. Now if we test the game, now we should see the humanoids moving around in their designated part. So we can see that this one always stays inside of this part, and this one will walk randomly either in this part or this part. Okay, now let's animate the NPCs. First thing I'm going to do is inside of replicated storage, I'm going to create a new folder and I'm going to call it animations. And then I'm going to steal my animations from my own character. So to do this, I'm going to play the game and I'm going to open the workspace and I'm going to open my character model, and under animate I'm going to steal the idle animation and I'm going to steal the run animation. So I'm going to copy these and then I'm going to stop the game and then I'm going to paste them into the animation folder and I'm going to rename them. So run animation and idle animation, and I'm also going to delete this wait number value from inside. Now I'm going to load these animations onto the NPC. So I'm going to come down to here and I'm going to say local animator equals instance.new animator, and I'm going to parent the animator to the model's humanoid like so, and then I'm going to load the animation by going local idle animation equals animator load animation game.replicated storage animations idle animation, and I'm going to do the same for the run animation. So run animation. Now I'm going to set the priority of the animations. So idle.animation t equals enum dot animation priority idle, and I'm going to do the same for the run animation, and we're going to set this one to movement, and I'm going to instantly start playing the idle animation. And I'm also going to play the run animation when we start moving the character. So play, and we also need to detect when the movement has finished to stop the run animation. So to do this, I'm going to say model.humanoid dot move to finished, and I'm going to connect a function to this event, and this function is going to pass us a boolean which is called reached, and if the NPC fails to reach its move to destination, we're going to just simply teleport the NPC to its destination. So if reached equals false, then I'm going to teleport it to the destination. And I'm also going to stop the run animation. And now that we know that the NPCs walk to the parts correctly, I'm going to now destroy the part and remove the can collide equals false. And I'm going to test the game. And we can now see that the NPCs are animated. Now I'm going to further optimize the NPCs by only displaying the NPCs that are within a certain range of the character. So to do this, I'm going to first, instead of passing the position directly into the move to function, I'm going to store this position in a variable, so local position equals, and we're going to pass the variable into the move to function. And then I'm going to check the distance from my camera's focus position. So if workspace current camera focus dot position negative position dot magnitude, and I'm going to say, for testing purposes, I'm going to set a low value of 100, then else. So if the position is greater than 100, I'm going to set the model's parent to game.replicated storage, and if the magnitude is less than 100, I'm going to set the parent back to folder. Now when we first enter the game and loop through the folders, instead of putting the model straight into the folder, the NPCs are going to first start inside of replicated storage. And once I've placed the model into replicated storage, I'm going to also teleport it to the position, like so. And now we're only going to move and animate the model if the model is within 100 studs. So if we test the game now, we can see that this model is being displayed and this model has now popped in. And if we walk away from that model and wait for it to move, you can see that the model has disappeared. And if we walk back towards the model, we can see that the model reappeared. Now, if you don't want pathfinding in your game, you can use this as your final code. But if you do want pathfinding in your game, what you're going to need to do is create a variable and I'm going to call it pathfinding service equals game get service pathfinding service. Then we're going to create a path by going local path equals pathfinding service create path, and we're going to pass in a table inside of this table. We're going to have a value called a key called agent radius, and I'm going to set the radius to 3, and we're going to have a key called agent height, and I'm going to set the height to 5, and I'm going to have a key called agent can jump, and I'm going to set can jump to true, and then we can have a key called waypoint spacing, and set this to 4. And now we're going to have a key called costs, and this is going to be equal to a table, and I'm going to set a material to have a higher cost so that the NPC will refrain from walking on water. So I'm going to say water equals 20. The default value is 1, so everything else will have a cost of 1, while water will have a cost of 20. Currently, this costs value is a beta feature, and in order to activate it, you want to come over to beta features, and you want to enable pathfinding modifiers. Now we need to create a table that's going to store the waypoints. So to do this, I'm going to create a new variable called waypoints, and I'm also going to create another variable called waypoint index equals nil. I'm now going to create a function, so local move to next waypoint equals function, and then I'm going to increment the index by 1, and then I'm going to store the next waypoint in a variable called wp equals waypoints. Actually, I'm going to call it waypoint, and I'm going to use the index as the key, and then I'm going to say if waypoint equals nil, that means we've reached the final waypoint. I'm going to then, we're going to stop the run animation. So we stop the run animation, and then we're going to return out of this function. But if the next waypoint does exist, we're going to continue by moving the model's humanoid to the waypoint's position, and then we're also going to check the waypoint's action. So if, let's say, if waypoint's action equals enum dot path waypoint action, and if it's jump, then we're going to say then model dot humanoid dot jump equals true. End. Now when the move to finished event is called, this means that we've reached the waypoint. Now instead of just simply stopping the run animation, we're now going to attempt to move to the next waypoint. So we're going to replace the run animation stop with move to next waypoint. And now when the attribute changed event is called and the position attribute has changed and the NPC is within 500 studs, instead of simply moving the humanoid directly to the position, we're going to replace this and we're going to compute the path To do this, we're going to say local success returned equals pcall, and we're going to pass in the compute async function, so path dot compute async, and then we're going to pass in the path variable, and then we're going to pass in the model dot primary part dot position, and then we're going to pass in the target position. So this is going to use the path compute async function to compute a path from the model's current position to the new attribute's position. Then we're going to check to make sure that this function never failed. So if success equals true and path dot status equals enum dot path status dot success, then now if the path was successful, we're going to get the waypoints. So waypoints equals path dot get waypoints, and then we're going to set the waypoint index to the first waypoint, and then we're going to start the run animation, and then we're going to attempt to walk to the second waypoint. But if the compute async function fails, or if the path status is not success, then we're going to simply teleport the model to the new position. I now placed some parts as obstacles, and let's see if the NPC is able to reach its destination. So here we can see the NPC just walked from here to here, and now he's walking back. And he reached his destination. I've just noticed a mistake. On the move to finished event, if the reached equals false, which means that the NPC failed to move to the next waypoint, instead of teleporting the NPC to the next waypoint, I'm teleporting the NPC to the final destination, which is incorrect. So what we need to do is, instead of getting the attribute like this, we need to get the waypoint, the current waypoint, and we want to get the position of the waypoint. There we go. So now if it fails to reach to the next waypoint, it will simply teleport to the next waypoint position. Okay, so now let's overlook the entire code. So if we look from the server's script, we can see that first we're creating a table called characters, and then we're defining a function called getPosition, and then we're looping through every child inside of the characters folder, which is this folder here, and for every child we are creating a data table, and then we're looping through every child of this child, so of this dummy folder and this dummy folder, and for every part inside of these folders we are creating a table, and we're storing the C frame and the size into the data table, and then we're destroying the part, And then we add in the data table to the characters table using the folder as a key. And then we're using the getPosition function to store an attribute, which is called position, into the folder. We're then creating an endless loop, and we're looping through every item inside of the characters table, which is passing a folder as the key and the data. And then we're updating the position attribute by using the getPosition function. And then once we've updated the attribute, we're waiting 5 seconds before we update the next character's position. The way the getPosition function works is we're first getting the data table from the characters table using the folder as a key, and then we're selecting a random table inside of the data table, which is this table here, and we're using the size key to calculate a offset vector 3 using the x-axis and the z-axis. And then we're using the C-frame that we stored to call the point to world space function, and this will convert the size offset to a world space position, and we're returning that position back to whoever calls this function. On the client side, we're first creating a variable called Pathfinding service, and we're using the getService function to get the pathfinding service. We're then creating a path object using the createPath function, and we're passing in our values. We're then looping through every child inside of the characters folder, which is this folder here. And for every child, we are creating a model which we are cloning from this characters folder, and we're using the name of this folder to determine which model to clone. We're then setting the model's C-frame to the position of the attribute that the server set on the folder. We're then setting the model's parent to replicated storage, so the model will be placed inside of here. We're then creating an animator and parenting it to the model's humanoid. We're then loading the idle animation and the run animation. We're setting the animation's priority, and then we're starting the idle animation by playing it. We're then creating a waypoints variable and a waypoint index variable. We then define a move to next waypoint function. We're then setting up a move to finished event, which we'll call this function here. And we're also setting up a attribute changed event, which we'll call this function here. When the server sets the attribute of a folder, this event here will fire, and we first are getting the attribute and storing it in a position variable. Then we're checking the distance between the camera focus position to the new attribute position that we just received. And if the magnitude is greater than 500, we're placing the model back into replicated storage, and we're instantly teleporting the model to the new position. But if the magnitude is less than 500, we're placing the model into the folder, which is either this or this folder, and then we're computing the path from the model's current position to the new position that was just updated on the attribute. And if the path was successfully computed, we then get the waypoints and store them into the waypoints variable, and we set the waypoint index to 1, and we start the run animation. Then we attempt to move to the second waypoint. If the path fails, then we will just simply teleport the model to the new position. When the move to next waypoint function is called, we first increment the waypoint index by 1. So we initially set it to 1 and it's incremented to 2. And then we attempt to get the second waypoint from the waypoints table. If the waypoint is equal to 0, that means the second waypoint does not exist. So we stop the run animation and we exit out of this function. But if the second waypoint does exist, we tell the model's humanoid to move to the second waypoint's position. And if the waypoint's action is equal to jump, we tell the humanoid to jump. When the humanoid reaches the second waypoint, the move to finished event will fire. If reached equals false, meaning it failed to reach the second waypoint, we will teleport the model to the second waypoint. And once we've teleported to the second waypoint, if it hasn't reached, or if it has reached, we'll just simply call the move to next waypoint function once again, increasing the index from 2 to 3. And now we'll attempt to get the third waypoint. And if the third waypoint doesn't exist, we will stop the animation and it will keep going back and forth until we reach the last waypoint. If you're not using my Infinite Terrain plugin, you can skip this part of the video. But if you are using my Infinite Terrain plugin, you may notice that sometimes the NPC is placed into the world before the terrain has had a chance to load. So I'm now going to show you how to check to see if the terrain has loaded to know if it's safe to place the NPC into the world. First, I'm going to convert my terrain script into a module script. So I'm going to create a module script and I'm going to copy and paste the code between these two lines. And then I'm going to move the terrain data into the module script. And I'm also going to rename the module script to terrain. And now I can delete the original terrain script. At the very bottom of our new module script, I'm going to create a new function and place it inside of the modules table. So I'm going to create module.isLoaded equals function. And we're going to pass two variables into this function, one called position X and position Z. And then I'm going to convert this position into chunk positions. And we can see that I've already done this here, so we can just simply copy and paste this code. And I'm going to create a local variable, and this is going to be called chunk X. And this is going to be called chunk Z. Now I'm going to see if the chunk has been loaded, and we can see that I've already done this here. So we can copy and paste this. And I'm going to say if chunk X equals 0, then we're going to return false. And if chunk XZ equals 0, then we're going to return false. And if it bypasses both of these checks, then we're going to return true. Inside of the local script that controls the NPCs, we're going to require the terrain module. So I'm going to say local terrain equals require game.replicated first terrain. Now let's use this terrain module to see if it's safe to place the NPC into the world. So instead of passing the model's position directly into the compute async function, I'm going to store the position in a local variable called model position, and I'm going to replace this with the variable. Okay, and then now we're going to use the terrain module. So I'm going to say or terrain is loaded, and we're going to use the model's position. So model.x, model.z equals false, or we're going to do the same for the final attribute position. So what we're checking here is we're first saying if the distance from the camera focus position is greater than 500, or if the terrain has not loaded at the model position, or if the terrain has not loaded at the final position of the attribute, then we're going to not place the model into the folder, but place the model into replicated storage. Thank you for watching my video, and if you have any questions, feel free to leave a comment, and I'll speak to you soon.